Hey everybody, welcome to video 42. This is going to be talking in some detail about the electron. It's called the quantum mechanical model of the atom, and it describes what electrons are doing around the nucleus. So like I was saying, quantum mechanics help us determine where electrons are in an atom. Now, as you can imagine, as small as atoms are, that's no easy feat. I mean, we're talking about really small things, and so just keep in mind that this is a model, okay? But it's been substantiated by a bunch of people a bunch of different times. So here's what we know. Electrons exist in regions of space that are called orbitals. You want to remember that word. There are four types of orbitals. There's S, there's P, there's D, and there's F. They're represented by four letters. Now those letters actually stand for words. You don't have to know the words, but in case you're curious, S is for sharp, P is for principal, D is for diffuse, and F is for fundamental. So electrons hang out in orbitals, and there's four different types. The s orbital is the simplest. Now notice the x, y, z's, you know, the three axes in space. Imagine that the nucleus is right in the middle of that thing, right in the middle of that sphere. Now that sphere is three-dimensional. Okay, sorry, that's supposed to be a plus right there in the middle. That sphere is three-dimensional. You know, the z-axis there, you know, how the coordinate axes work there help and reinforce the fact that we're talking about a three-dimensional object that is spherical. The electrons that reside in there occupy that entire space around the nucleus. Okay, but it's a very simple shape. It's a sphere. You know, if you rotate that thing 80 degrees, it's going to look just like that. You rotate it 130 degrees, it's going to look just like that. So there's only one way we can orient this s orbital where the electron hangs out. Now, what the electron is doing in there, we don't know. We'll talk a little bit about that in class. Okay, that second type of orbital, P, looks like a dumbbell. You know, like a figure eight sort of. You know, there's two lobes on it, in other words. And each, since it has two aspects to it, it can be oriented in three different ways on the coordinate axes. One way can be along the x-axis, one way can be along the y-axis, one way can be along the z-axis. You put it all together and it looks like this. But the point I want to make is there are three orientations. This is a more complex shape than the one we just looked at. So we can orient it three different ways on the coordinate axes. So we have three P orbitals. That's why I put an S there. The P shape is dumbbell, but there's three orientations. The D orbitals have five different orientations. Notice there's four lobes, and of the five different orbitals, four of them just change their orientation around the three axes. This one is just, we're not even going to talk about that. But anyway, the D's can be five different orbitals. Are you seeing a trend now? The S, one orientation. The P, three orientations. Now we're talking about the D's with the five orientations. Guess what's next? Yeah, the F's. This is kind of a crazy looking picture here, but there are 7 different orientations for the F orbital. And that completes, you know, what we see as the pattern. S, 1 orientation, P, 3 orientations, D, 5 orientations, F, there are 7 different orientations of the F type of orbital. Now these shapes are even stranger than that 1D we were looking at. But don't worry about it. You just need to know there's 7 different orientations. The S, you need to know that's spherical. The P, yes, that's dumbbell. You know, the D-shaped, You just need to know there's 5 different orientations. In the F, there's 7 different. So looking at them all together, you can kind of see it more clearly. The S, as the simplest shape, has just one orientation, but the P, because of its shape, can be oriented on the 3 axes in 3 different ways. With the D's, we have 5 possibilities for orientation, and with the F's, we have 7 different possibilities for orientations. S, P, D, and F. Now this may be the most important thing we talk about. Each orbital, each orientation that we just looked at, or orbital, can hold a maximum of 2 electrons. So the S orbital, since you can only orient it one way, it can hold a maximum of just 2 electrons. But the P orbital, since it has 3 different orientations, each one of those can hold 2 electrons. It can hold a total of 6. The D orbital, since it has 5 different, since it has 5 different orientations, each one of those can hold 2 electrons. It can hold a total of 10. And then the F's, since there are 7 different orientations, each one of those can hold 2. That gives a total of 14 for the F. So to sum it all up, S can hold 2 electrons, P can hold 6, D 10, F can hold 14 electrons. Now these orbitals that we've been talking about, they hang out, they exist in energy levels around the atom. And so by energy levels, we mean regions of space that are successive distances around the nucleus. Energy levels tell us 2 things. 1, how far an electron is from the nucleus, and 2, how much energy the electron has. So an electron that's in the first energy level is closer to the nucleus and has less energy than an electron in the second energy level. And that electron is not as far from the nucleus and has less energy than an electron in the third energy level, and so on. Alright, follow this closely here. The first energy level only has one type of orbital. Notice 1, 1. First energy level only has the S. And so since that's the only orbital it has, it can only hold 2 electrons. The second energy level has 2 types. Second, 2. S and P. Now you know that the S can hold 2 and the P can hold a total of 6. So that means the second energy level can hold 8 electrons. Third energy level has 3 types. Third has 3. The S, which can hold 2, the P, which can hold 6, and the D, which can hold 10. So that's a total of 18. The fourth energy level has 4 types. The fourth has 4 types. S, P, D, and F. The S can hold 2. The S can hold 2. The P can hold 6. The D can hold 10. And the F can hold 14. So that gives us a total of, 8 plus 24, 32 electrons, okay, that can hold in the fourth energy level. So what does this look like? Well, if you imagine the 3 axes in space there with the nucleus right dead center in the middle where they all meet, that's what it would look like with the 1s orbital. Okay, imagine that as a spherical object, 3 dimensions. If you add a 2s orbital to that, it's just the same shape. I mean, S has that spherical shape. But what's the difference is, since it's 2s, it's farther from the nucleus. Okay, but it has the same shape because that's the S shape. But since it's 2s, it's farther from the nucleus than 1s. So here's an atom that has the 1s, that's the one in the middle, okay, and it also has the 2s, alright, that's farther from the nucleus but still spherical because it's s, but we've added a p orbital The blue thing in there is the P shape, and notice that it extends all the way out to the second energy level. That's why it's 2p. And here's a picture of what it looks like if we add a second p orbital. Notice the red in there, okay? So we have the 1s in the middle, the 2s is the same shape but outside, and then we have an additional 2p orbitals. They also extend out to the second energy level. Here's an atom with 1s, 2s, and all three 2p orbitals. How many electrons are in this atom? Think about that, figure it out. Thanks for watching.